Yeah, so Don's told me that there are a few of you using Numbas at this session. I recognize a few names, but I thought it would be worth doing a little bit of an introduction for those of you that haven't seen it before. So I'm not going to do my normal spiel of slides and stuff because I want to do some more complicated stuff later. So what I'm going to do instead is I'll quickly turn on my screen if I can find it. There we go. So this is the Numbas website. It's numbas.org.uk. You might be able to see the address at the top there. So very briefly, I'll try and spend 5 minutes or so given the basics of what Numbas is. It's an online assessment system designed for maths, or developed originally within the School of Maths, Stats and Physics at Newcastle, but it's used for all sorts of other subjects as well. But since this is a maths meeting, I'll try and concentrate on maths. The idea is it all runs inside the web browser, which means you get immediate feedback. You don't have to call off to a server somewhere to get stuff back and have answers checked. It's all very instant. And it does loads of stuff. So I'll quickly show you the demo, just to show a few of the things it can do. So this is the our demo exam. It's in menu mode, which means I get shown a list of questions here to pick from. My first few are to do with the kinds of questions you can ask. And then I've got some more complicated stuff, but the rest of the talk is going to be about that, so I won't show those. Before I carry on, this is the sort of time of day when I start to say nonsense, and so I will happily take any interruptions or questions throughout this. Yeah, so if you notice something along the way, just interrupt me and I'll happily talk about that. I don't have a very fixed plan for what I'm going to talk about. Yeah, so this is what Numbas is really. I think everybody's got some experience of online assessment now after the past couple of years. So you're shown a question, you enter an answer, and you get some feedback immediately. So it's not so late that I can't answer this, I say, in a fit of hubris. Yeah, there we go. So you can take numbers, you can take mathematical expressions. Can I differentiate past my bedtime? Yes, I can. So the idea is all about ease of use. The interface has been very carefully designed and giving lots of feedback to students. There are loads of different kinds of parts. One of the real benefits of computer-based assessment is the ability to randomize questions. I don't know if I've got any really good randomized things here. Should find some randomized stuff. My demo exam doesn't have too much randomization, but anyway, that's a real benefit of it. And we've found that e-assessment like this is really good for formative use, for giving students access to stuff that lets them practice in their own time and sort of decide what they want to do. We also, because of circumstances over the last couple of years, have used Numbas for a lot of high stakes summative tests as well. Yeah, so I think that might be, I actually can't see the time. There we go. That might be the very, very briefest introduction to what Numbas is. What I wanted to do today was to talk about some of the more adventurous things you can do with Numbas. I know we have a few fairly experienced Numbas users here. And I thought I'd just show off some of the stuff that I don't normally get a chance to talk about. There's absolutely tons in Numbas beyond what you would encounter just if you were trying to quickly set stuff up. there are loads and loads of features. It's been in development for over 10 years now. So I thought I'd go into a bit more depth in some of those. So what I've done, I've got my Christmas jumper on, maths on it, of course. I've written a Christmas question. And the idea here is I sat down and I wrote down a list of the things that I wanted to cover, and I've managed to pile it all into this one question. I think I'll run it and show you what's the deal. So first of all, this is an explore mode question. You might have only written the show all parts type previously. So normally, actually, if I flip back to the demo, where is it? There we are. A numbers question, you're shown a list of parts and you have to answer each of them. They're separate, they don't really, like one is supposed to lead on from the other, but you don't have too much adaptive relation between them. This explore mode question, the idea is to let the student choose their own path through the question. So maybe not even a question, an activity. We use this quite a lot for lab activities in some of the scientific subjects and engineering. So here I've got a few choices. The setup I've gone for is you are Santa's most important helper. And there are lots of jobs to do. So I've got 3 jobs here and I can pick what order to do them in. And each of those is going to show off a different feature of numbers. So I'll show you how this goes in the editor. I'm going to flip back and forth between this question and show you how I've implemented it. An explore mode question is, what do? You define a list of parts. I'm just trying to move zoom out of the way. There we go. So here are the available parts in this question, and you start at the very first one and you just define links from one part to the next. You can give a condition on when a link will be available, and you can replace variables, which is a way of sort of having some kind of state that follows you through the question, or keeping track of what you've done so far. So what I'm going to do first of all is pick this first option here to make the naughty and nice lists. And this is one use case for explore mode, where I'm going to ask for some free input from the student, me in this case, and then the next part, ask a question based on that. So here I've got to make up the list of who's naughty and who's nice. As I'm going through this framing is starting to grate on me a little bit, so hopefully you can bear with it as well. So I've got to pick a niceness score above which children will get a present from Santa, and beneath which it'll be coal. So what score shall I get between 0 and 100? I'm going to pick 50, exactly midway. So I've done that. I've entered an answer. I haven't got any marks, but now this option to move on has appeared. So what that did when I opened that link, I'll go back and find it. There we go, back in the editor. In the next parts, that option becomes available when the answer is submitted, and replace the value of this variable, a nice threshold, with what the student wrote. You can pick all sorts of conditions for when things appear. You can even write your own, just a free expression. And the same with variable replacements. You can use the student's answer, or the amount of credit they got for the question, or something else in terms of 2 of those, I guess, or any of the bits of the marking algorithm. So over here, here's the part that was generated based on that. It says there's the number I gave, must obtain a score of 50. And here I've got some randomly chosen people, some names and some scores. And I'll show you how that works as well. So if I have a look at that part, make the naughty and nice list. Here's my text, and it says make a table out of the children's names and the children's scores with headers name and score. So those are question variables. I'll go over here and find all of the variables I've defined for this question. No, I'll appreciate being able to see some of you nod along, so I'm going to move Zoom back over there. So there's absolutely loads in this. I've spent all afternoon making this, and I've got loads of stuff I want to show you. Here are the variables for this part of the question. Something that's worth doing, or getting in the habit of doing, is splitting up the variables in a question into groups just to organize it. That's one of those little features that just makes working with the editor a bit nicer. So the names, first of all, I used the random person extension, which is something we wrote after having written a load of word problems with named characters and trying to really represent fairly the names of the population, and specifically the students that we get. So this picks names based on statistical data from the UK, children born in the past 18 years, so sort of our student cohort. And then the scores, what I've done, I've just chosen random numbers between 0 and 100 for however many children I want to have. So that's sort of set. That didn't depend on my input. But then the question, well, the thing I'm asked to do is to classify these as either naughty or nice. And that does depend on the score I gave. So I'll go back, and that's this marking thing here. So for each child, so for each score in the children's scores, if their score is over the threshold, then nice is the correct answer. Otherwise, naughty is the correct answer. So I can do this now. So this marking then depends on my input. And I think that's a really nice way of making up a formative question to sort of let the student pick what kind of question they're going to have, rather than sort of just writing a fixed question or relying on randomization to show you, eventually show you all of the different variations of the question that you might want to see. So I'm going to have a go at this. What does I say? It had to be 50. So nice, nice, naughty, nice, and nice. And then we go submit part. Then we've got this option to go back, and that will only appear once I've got this question completely correct. Something else that we do in explore mode questions is if you get partially correct or you get the answer incorrect, you might offer a hint only once you've entered an answer. So we've gone back to the sleigh, and I can show you my next clever trick. The sleigh didn't have a present in it before. This is an SVG file. It's something I drew in Inkscape, which is a program for doing vector graphics. And it's put into the text here. And you can, because SVG files are, they're not like a flat image that's fixed, you can control the attributes of things in the picture based on question variables. So there are a load of presents here, and they are shown or hidden based on how many of the jobs you've done. I'll quickly show you how I did that, but it doesn't look very nice, because this is what an SVG file that comes out of Inkscape looks like. It's got a whole load of rubbish. I had to go into the code and find this group for each of the presents that I made, and say, add this attribute here. So change the opacity. It's either 1 if you've done however many jobs correspond to that present, or 0 otherwise, using the award function. So that's a really techie thing to do, but I think it's a nice little trick. Okay, So I'm going to go on to my next thing. I'll get through this very quickly, I think, and there'll be plenty of time for questions. So the next thing I wanted to show was extensions and custom part types. So here on this one, it's, again, it's sort of free input, but a nice framing for that, or a nice pattern to do, is to ask the student to make an estimate before they do a real calculation. This might be a kind of Fermi problem, really. So suppose Santa does have to deliver all these presents to every child in the world, plus or minus cultural differences. What would that weigh? So make an estimate for how many children there are in the world and how much one present weighs. And then on the next step, or I haven't set a condition on that, we'll estimate the total weight. So it's very late here. I don't feel like doing any hard maths at all. I'm going to say there are 100 children in the world. One present weighs 5 kilos. I think unrealistic answers for both. I've put kg here. This is not one of the built-in part types. This is what I wanted to show you. This is the quantity with units custom part type. So there are loads of these. There are a few that are that we've published that you can use in your own questions, or quite often I find when I'm writing questions for an unusual course, I'll make up a custom part type for the kinds of questions that come up very often. So I'll go to that and find that quantity with units. So this is defined somewhere. I could show you that. I will. But you get a load of settings in the editor. It works just like any of the built-in part types. All I had to really do here was to write that correct answer, and I was happy with all these default settings. It's got loads of settings. And what this lets me do is ask the student to give some units with their answer, and they can give it in grams or kilograms, or I guess pounds even. And the way it's set up here, it will convert between those. So I'll go back to the question. I can't see the chat, by the way. I'm just going to shift the chat over here. There we go. So I've answered that. I'll move on. And now I have to do this calculation. Again, I've done variable replacements, so I can show these numbers that I put in. So I'll try 500 kilos. That looks correct. I'll try 500,000 grams. Was that enough zeros? Yeah, that was enough zeros. So if you haven't before, have a look at setting up a custom part type of your own. Just if you find yourself setting the same sort of question over and over, it could be easier just to sort of set that up as a custom part type, so that all you have to fill in is one settings field instead of setting up the number entry thing every time to do whatever you want and copying scripts all over the place. Right, there's job 2 done. Right, okay, so now we've got 2 presents, and something else I haven't shown you about this picture is it's got alt text. Accessibility is very important. It's important that everybody is able to use the e-assessment or the material that we offer. I think here in the UK, it's now a legal requirement that we make everything accessible. I don't know what the case is in Australia. So how have I made this image? I will show you. And it's got some alt text on it, which I will also show you. So I'll find, no, it's over here. I've made a custom function. So one of the really important things about Numbas is that you can extend it in just about everywhere, every direction. Because Numbas is designed for maths, and maths is such a huge and varied subject, there was no chance that you would be able to build in everything that you want to do. So in addition to being able to make stuff up with variables, you can define your own functions, and you can make new extensions which bring in code from somewhere else. So I've set up this function to produce the sleigh image. I uploaded it as a file in the resources section here. But what have I done? I've said embed it as an object, ignore this sort of curly stuff, and then here's the alt text. Santa's sleigh with however many presents on it. That's a good description of that image. That's functionally what it's for. And to come up with that presents text thing I've done here, let, so I can make up a new variable just here. So based on the number of jobs done, it's either one present or the number of presents written out as an English number. I'm jumping all over the place here because doing each of these things, I needed to do lots of them at once rather than showing you stuff in isolation. So the written number extension is the one I wanted to show you as an example of how easy it is to write an extension. Assuming you've written a load of basic stuff in Numbers, and what's the next step? I think writing an extension is potentially that. This is one that came out very quickly from a suggestion on the Numbers users list. I really like getting feature requests and suggestions. So this inspired that. The idea was you've got a number which computers are very good at displaying in sort of decimal form, but what if you want it written out in words? So I thought, well, there must be some code somewhere that does this for me, and there was. So I found that and wrapped it up as an extension in Numbers. So there's, when you create an extension in the editor, you sort of get some boilerplate, you get some stuff at the top that you have to make, and then there's some things here. There's documentation about all the bits of code that you need. But the basics of it is, this is JavaScript, by the way. I appreciate there will be people here who don't have any coding experience and will be well lost at the moment. But anyway, the point is, down here, I've copied in this library that I found that writes a number out, and then I've defined a couple of new functions in JME, or the same one with a few different ways of calling it. So when it takes a number, it returns a string, and it calls out that function which the library gave me. So really simple to add a new function into Numbers, and then, as you saw, I could just use it throughout the question without having to write a load of complicated code. So this is something I do quite often for supporting colleagues writing Numbers stuff. Yeah, right. So where had I got to? Oh, that was a digression about alt text. So yeah, I'm embedding this image. Each time it comes up, I'm changing the alt text. In order to make the alt text, I use this library I found, which writes out a number in words. Right. One job left to do is to pack the presents. So this is about designing a box. I thought this was the simplest sort of geometry thing I could think of. Here I want to show you, this is a JSX graph diagram. JSX graph is a really good package for presenting interactive geometry. I know that there are a few people here who have used GeoGebra a lot. That's also really good, and there's a Numbers extension for that too. But JSX graph is the one I've done the most recent work on, so that's what I'm showing you. So the idea here is I want to design a box. I want it to have an area within these bounds, so between 1.1 and 1.5 meters squared. And what I need to give is the width and the height in centimeters. So I could just type in here and submit it, and it would mark that. But what JSXGraph lets you do is sort of have a link between the written form of an answer and a visual form. This is really simple here. It's just like linking numbers up to sizes. But other examples we've had of sort of like linking the algebraic form of a parametric curve to the way it's drawn. It really helps cement that link in students' minds. So what I can do is I've got a point and I can drag it to say how big my box should be. And as I move it, that fills in those boxes. And also, if I get rid of that, I can type in here. So I can say 200. And that will update the display as well. So it's actually quite easy to set up that link now in Numbers between input boxes and the diagram. It might not look it when I show you. So I'm going to try that. I think that's in the right range. Yeah, that's good. So the area of my box is 1.2 meters squared, and I get some feedback there saying that'll do. And I haven't really set up any marking for this question because that's not the point today. So how's this working? How's that marked? This is a gap fill part. So I have two boxes here where I enter an answer, and I have a custom marking algorithm which takes both of those numbers, works out the area that they correspond to, and then checks it's in the right range. Custom marking algorithms are another really powerful feature of Numbers, where when the built-in part types and the built-in marking algorithms don't do what you want, you can just make up your own marking logic. So I will show you how that's done. All right, I need to move a load of Zoom windows around. I've magnified everything to make it easier for you to see, but that makes it harder for me. Pack the presents, there we go. So I had a few things to show you there, didn't I? I had to show you how the JSXGraph diagram was made, and then how the marking works. I think the marking's simplest, so I'll do that. Ignore that, that's the built-in marking algorithm, which I don't want. Right, so in Numbers, marking is done by these, it's called a marking algorithm, it's really a script, it's a load of code. And they work sort of the same way as the question variables are made. You define a load of things, and then they're all evaluated, and then there's a couple of special ones. There's mark, which is supposed to produce the feedback, and then there's one called interpreted answer, which I'm just reusing from the built-in, which says what the student's answer to that part was for anything else in the question that wants to use it. And the idea is you sort of like build up notes about the student's question. You have individual bits that just check something, and they build up in bits of feedback. And then that might eventually come down to one test that says it's completely correct or not, or you might have a few properties you want to test that each give a little bit of the credit and a line of feedback. So here, the built-in algorithm is already doing the job of using these gaps to get their answers out as numbers. So the student types something in, it might represent a number or it might not, and the built-in marking algorithm is in charge of telling them that I can't interpret that as a number, try again. So we use all that, and then here get those numbers. So the width is the first gap and the height is the second gap, and then the area is width times the height. We asked for it in centimeters, but then we're going to compare in meters squared, so I've divided by 100 squared there. So now the marking, the producing the feedback, I have to decide if the student's answer is valid. I have to maybe give some feedback messages and decide how much credit to give. So here first of all, I assert that is nan means is not a number. So that's a way of saying, could we not interpret what the student wrote as a number? If either of them are not a number, then we'll just fail marking completely here and say you must give a number for both dimensions. I didn't spend the time going into more depth, giving something more helpful for individual ones, like saying, you could say the width doesn't look right, but that's just a simple message there. So the next thing is, I thought I'll tell the student what the area is, which if you'd been thinking about this carefully, that you might use that to check that you've done your calculation right. And then some logic here. So if it's bigger than the minimum, that's good. If it's smaller than the maximum, then mark it correct and say that'll do. If it wasn't smaller than the maximum, then you can say it's too big. And then the final case here was when it was less than the minimum. So say that's too small. So those are the kinds of feedback you can get. And I'll go back to the question. Where was it? There we are. So I'll try and get one that's far too big. There we go. So the area is that. It's too big and too small. And here's what happens when you don't give a number. And one of them's not valid. In fact, I get a warning in this box anyway, because that's the built-in algorithm did that for me. Yeah, so I think that was fairly straightforward, as much as it looks a bit like code. So you can do absolutely tons with custom marking algorithms. Yeah, right. The last thing to show was how to get that diagram to work. It's defined as a variable. Where was it? Over here. Wow, the wrapping on that. I'm going to have to zoom out a bit just to make that look not awful. So JSX Graph has its own scripting language called Jessie code, which I've used. You could easily, I think, produce this just using Numbas' JME code. But anyway, I create a point and sort of draw a polygon whose corners are defined by that point. And I've defined what that's the bounding box of the diagram, so the coordinates of the corners, and that's how big it appears on screen. So I use that. I can then put that into the part prompt, which I'll find. Where is it? Yeah, so that's where that diagram goes in. And the JSX Graph extension sort of takes care of making all that work and then rendering it and making it interactive. To get the link with the input boxes, I'll go over to these. The JSX Graph extension looks for a couple of notes in the marking algorithm. One for input, which says, after the student's answer to this box changes, update the diagram. So if the student's answer was valid, effectively, then set the position of that point A, updating the X coordinate with what the student wrote for this. That's it. It can do a whole list of actions. It can move all sorts. If it's a complicated diagram, it can move all sorts of things. It can change the radius of a circle. It can change the color of something. You can do all sorts. And then the other direction, if you move the point on the diagram, fill in the box. So whatever this thing produces is what will go into the box. So format to 0 decimal places, get the position of point A and the first coordinate, which is the X coordinate. So get the X coordinate and write that out as the input. Again, this is really, there's so many ways for this to go wrong. And I think this is a really good model for making the link between an interactive diagram and a box where you can type something, which is supposed to correspond to something in the diagram. These two aren't necessarily strictly linked. Like changing something in the diagram could fill in the box, but typing the same thing in the box might not produce the same diagram. Yeah, so there you go. Zoom back in again. Get to where we were. I've got to get this right in order to get the point, haven't I? In order to fill that sleigh up. There we go. Go back to the sleigh. So now sleigh is full. This text has changed. It says you've got all three presents. But I think the last thing that I wanted to show you, is it the last thing? Maybe. Something that I haven't really used too much because I haven't written too many questions lately, but I think is really, really worth doing. And I don't think it's complicated, unlike the rest of the stuff I've shown you, is where's this part? So here's I keep coming back to this part called the sleigh. That's the one that's sort of meant to show your status and then give you some options about where to go. And that renders the status display as a HTML because it produces that image and then also the line of text. So it can't just be a plain text string. And the reason I haven't just written that in the content area there is so I could use that in every part prompt if I wanted. Let's go and find it. So that's a variable. It depends on the list of jobs that I've done. So by the way, each time I was completed one of those jobs and I clicked the next part link to go back to the sleigh, it was updating one of these things here and saying it, switching it from false to true. And then I have some logic to work out how many of the jobs are done based on that. So what this was doing was, if I've done all the jobs, then show the finished text, otherwise show the still collecting things text, which I'll go to there. So this is a variable, but it's not the code editor. I've used the formatted text data type and ticked, is this a template? So that means I can write out some text and have some variable substitutions in there, but those don't happen until it gets actually put into the text. I can have lots of copies of this. Yeah, so there's my function which produces the image. I could have just pressed a button and had that static image there if I'd wanted, but I was doing clever stuff with drawing the image. And then it says you've completed how many of the total jobs. And I think the finished one is the same. So the text is a bit different. Yeah, and I think that's, I quite like this idea of building really sort of a game or a choose your own adventure of an investigation activity. And you could use this to sort of display your status at the start, at the top of each part, have some sort of indicators that are always in the same place and help you track your progress. Okay, so I think I've got one last thing to do is to deliver the presents, and there we go. So I've used that status display again, and then I've just stuck an image in there, and it says Merry Christmas. Right, so I blasted through that, and because of Zoom, I haven't been able to tell who's been following along. So I think I'll stop there. And if you have any questions, I'm happy to answer them. I can go back to the more basic